Today's lesson is on multiple events. Your warm-up today is to identify the event. So it's either a single selection, multiple item single selection arrangement, and describe how you would find the chances of each event. Go ahead and pause the video at this time and determine which of the types of events letters A, B, and C are. For letter A, you should have gotten an arrangement. So you would find the answer by using a permutation. The key word here is the word lineup. Because the order in which the positions are chosen does matter, it would have to be a permutation. For letter B, if your coach is deciding the captain of the team, you would do a single selection. There is just one person that's being chosen out of the total number in your sample. And lastly, for letter C, if your coach is picking a group of people, it doesn't necessarily matter what order in which those students are chosen for that team. Therefore, it would be a multiple item single selection, and you would use a combination to find the answer to that question. Today, we're moving on to multiple events. So what happens when two things are happening at the same time, or when one thing happens and another follows? Starting with the word and, given two standard dice, what is the probability of rolling a double six? A standard dice has 6 sides to it, so the probability of rolling a double six would be rolling a 6 and rolling another 6. In words, it would be a 6 and a 6. The probability of rolling a 6 would be of the total 6 different outcomes in your sample space, you have one shot of rolling a 6. Rolling another 6 would be out of the 6 total in my sample space, I have one chance of rolling a 6. The word and means that we're multiplying, so the probability of 6 and a 6 would be 1 out of 6 times 1 out of 6, which is equal to 1 out of 36. To answer this question, I could also take into account what is the total sample space when I roll 2 standard dice. Last class, we familiarized ourselves with cards. Today, you also need to familiarize yourselves with rolling 2 dice. So what you have in front of you is the sample space when you roll 2 dice. One die is red, one die is green, and these are all the possible outcomes that we have. Rolling a double 6 within this 36 sample space would be one outcome out of the total 36 different outcomes in my total sample space. For question 2, if you were to draw 2 cards in succession without replacement, what is the probability of drawing a pair of aces? So this question would be drawing an ace and another ace. Similarly, we're going to find the probability of drawing that first ace. For the first ace, we know that from our entire sample space for a deck of cards, there are 52 possible outcomes, and of the 52, 4 of them are aces. So 52 is a total sample space, and 4 out of the 52 are aces. The word and we know means to multiply. The difference in this problem, though, is that now we are drawing without replacement, meaning that the first card that was chosen is not going to be put back into the deck of cards. Assuming that we already pulled out an ace, then we have 51 cards left in the deck, and of the 51, 3 of them are still aces. So the probability of this happening, 4 times 3 is equal to 12. 52 times 51 is equal to 2,652. And the probability of this occurring, if you were to reduce this, divide both the numerator and denominator by 12, is equal to 1 out of 221. So what makes the calculation of events 1 and 2 different? Well, in example 1, the first event does not affect the probability of the second event occurring. Me getting a 6 on the first one will have no impact on what happens to the second event. However, for the second problem, because we are doing it without replacement, the second event, the 3 out of 51, has less in my total sample space as well as one less ace in the deck. Therefore, we have two different types of events. One is called an independent event and the other is called a dependent event. In independent events, the probability of A and B occurring is equal to the probability of A times the probability of B. The first example is an example of independent events because the probability of getting a 6 and the probability of getting another 6 are completely independent of one another. So it would be the probability of 6 times the probability of 6, which is equal to 1 out of 6 times 1 out of 6. For independent events, you have two separate events, events A and B, where the probability of both A and B occurring is equal to the probability of A times the probability of B. How do you know that the two events are independent? B is not affected by the outcome of A. The second example is an example of dependent events. Probability of getting two aces in succession would be the probability of getting an ace times the probability of getting another ace, given that you got the first ace. As an equation, it would be the probability of both A and B occurring is equal to the probability of A times the probability of B, given A had already occurred. For this particular example, the probability of B given A means the probability of event B occurring given event A has already occurred. And for dependent events, we know that the probability of B is not equal to the probability of B given A. However, for independent events, the probability of B would of course equal the probability of B given A, since the event A did not affect B at all. So a common question I get asked is, am I able to use a combination to answer either of these questions? Well, we can try. So for the first example, we have two standard dice, meaning that there's a sample space of 6 for the first die. There's a sample space of 6 for the second die, meaning that there's a total of 12 in my sample space. And of the 12, I want to select 2. For my numerator, getting a double 6, it would be the combination of the two 6s that are in the sample space and picking both of them. For the second example, if I am to draw 2 cards in succession without replacement, the probability of drawing a pair of aces. Well, I know that there are 52 cards in a standard deck, and of the 52, how many different ways can I select 2 cards? That would be the total. In my numerator, for the pair of aces that I have, that means that I have 4 total aces in my deck. How many different ways am I able to select 2 of them? So my question is, can we solve these using a combination? The answer to the first one is no. And the reasoning for this is because I can't pick 2 numbers from one specific die. The sample space of the first die, or die number 1, is 1, 2, 3, 4, 5, 6. The sample space of my second die is 1, 2, 3, 4, 5, 6. It is impossible for me to just combine these 2 die together and then say that I am picking 2 from just one of the die. So the answer to this is no, I am unable to do this. I can't select 2 from one die. For the second question, am I able to use a combination? And the answer to this is actually yes, because I am selecting the 2 cards in succession from the same deck of cards. And so this one, if I did the combination of 52, 2, that means that there's 1,326 total outcomes. And how many different ways can I select 2 aces? It would be 6 out of the 1,326. And when I simplify this, I end up getting the exact same answer, 1 out of 221. So yes, I could have also done a combination to answer question number 2, which is similar to examples that we've seen last class. Number 3 states there are 3 quarters, 4 dimes, and 5 nickels in a purse. Suppose 3 coins are to be selected without replacement. So we are not putting the coin back into the purse after we have taken it out. What is the probability of selecting 3 quarters? Selecting 3 quarters means I am selecting a quarter and another quarter and another quarter. One way that I can solve this is to find the probability of selecting the first quarter. So of the 3 plus 4 plus 5, 12 total coins in my sample space, 3 of them are quarters. Since I am not replacing the first coin that I took out, I'm assuming that I have 11 coins left. And also assuming that I already had picked out a quarter, I only have 12 left in my purse. Lastly, for my third quarter, I have 2 less coins in my purse, and of the remaining coins, I'm assuming that only one of them is a quarter. So the probability of selecting 3, it would be 3 out of 12 times 2 out of 11 times 1 out of 10, which is equal to 1 out of 220, which is approximately 0.0045. For this problem, could I have also used a combination? The answer to this is yes. I also could have stated that I am selecting of the 12 coins, 3 coins. How many different ways can I select 12 out of the 3? And for my numerator, how many different ways can I select all 3 quarters out of the 3 that I have? Of course, logically, the answer to that should be 1, which is the combination of the 3 quarters and selecting all 3 of them. This would result in the exact same answer as the other method. For example B, what is the probability of selecting a quarter, then a dime, then a nickel? So I want to select a quarter, and then a dime, and then a nickel. Probability of selecting a quarter would be of the 12 total coins in my purse, 3 of them are quarters, so it's just a 1/4 probability. Selecting a dime. Now, I'm assuming that I took out 1 coin from my purse, which is a quarter, and of the 11 remaining coins, 4 of them are dimes. Lastly, for my nickel, assuming that I took out 2 coins already, I now have 10 left in my purse, and of the 10, all 5 of them are still nickels. So the probability of selecting a quarter, then a dime, then a nickel would be 3/12 times 4/11 times 5/10, which is equal to 60 out of 1,320. And when I reduce this fraction, it's equal to 1 out of 22. You also are able to leave it as a decimal if you want. It's equal to 0.045 with a bar over 4/5 since it is repeating. Please read question number 4 and attempt that one on your own. You can pause the video at this time. Lastly, for question 5, if you were to draw a 5-card poker hand out of a deck of cards, what is the probability of drawing 3 kings and 2 queens? So 3 kings and 2 queens. What we want to do here is first find the sample space. What is the total number of ways I'm able to draw just a 5-card poker hand from a deck of cards? Well, how many different ways can I get a 5-card hand out of the total 52 cards in my deck? That would be the combination of 52, 5. Of the 52 cards in my deck, how many ways can I select 5 of them? That would just be my denominator. And there are a total of 2,598,960 different ways to get a 5-card hand. Now, what is the probability of drawing 3 kings and 2 queens? I'm going to do each of these individually. These 2 are independent of one another because I have 3 kings and I have 2 queens. The 3 kings would be the combination of the 4 kings that I have, how many different ways can I select 3 of them, times the 2 queens. Of the 4 queens in my deck, how many ways can I select 2 of them? Well, there's 4 different ways I can get 3 kings, times 6 different ways that I can get 2 queens, which would be 24 different ways that I can get 3 kings and 2 queens out of the total 2,598,960. This would simplify to, I'm going to write it up here, 1 out of 108,290. For letter B, what is the probability of drawing a 4 of a kind? A 4 of a kind, 4 aces, 4 kings, 4 queens, etc. It's basically just getting 4 of the exact same card. So let's say that I want to find the probability of getting 4 aces. It would be the same denominator, the combination of 52, 5, because I'm still trying to find a 5-card poker hand. And in my numerator, it would be the combination of 4, 4. Of the 4 aces that I have, how many different ways can I select 4 of them? However, this would not be my final answer. And the reason for that is because right now, the 4 aces reflects the combination of 4, 4. However, there are many different ways that I can get a 4 of a kind. It could be 4 aces, or 4 kings, or 4 queens. There are 13 different kinds of cards in my deck. So I would take 4, 4, the combination of 4, 4, and multiply it by the 13 different ways that that could happen. So my final answer would be 13 out of 270,725. It's approximately 0.00048.